Welcome to today's chatter-io tech news with the top 5 stories of the day. So let's get into it. Can you trust your AI model's prediction? High model accuracy isn't enough. Conformal predictions guarantee higher coverage of true outcomes. Conformal predictions bridge the trust gap in machine learning by providing actionable confidence intervals for a set of predictions. By giving a set of predictions instead of just one, users are provided with multiple potential relevant scenarios. And this is very useful for high-risk situations, such as in medical diagnostics, where multiple scenarios should be considered instead of just focusing on one potentially wrong prediction. However, statistical guarantees don't equate to practical reliability in all cases, and interpretability challenges for end users could hinder adoption. It's just more difficult having more options to choose from. So these conformal predictions highlight really the importance of dealing with uncertainty, but achieving true reliability for critical applications remain a work in progress. How do AirTags really work? AirTags depend entirely on Apple's billion active devices worldwide, because AirTags send encrypted Bluetooth messages which nearby Apple devices can pick up and eventually transmit to the internet. This is a really innovative use of existing Apple devices for real-time tracking. And since AirTags only use Bluetooth, they don't require frequent charging, with batteries lasting a full year. But given that they lack an internet connection themselves, in rural or remote areas, location updates can be infrequent or, quite frankly, unavailable. Also, expect limited functionality in regions with few Apple devices. So buyers should pause if they intend to use these AirTags in non-urban areas. And key improvements for V2 would include broader compatibility and alternative tracking tech. AI DJ is Spotify's newest hit. AI DJ adoption rates outpaces Spotify's Discover weekly usage among its users. As Spotify's chief product officer, Söderström explains, the future of music lies in the interplay of AI and human creativity. AI DJ mixes music, but also shares stories on tracks and artists, just like a radio host. And this level of personalization really enhances user engagement. Moreover, recommendation problems become even more important as the music catalog grows. However, overloaded catalogs could worsen discoverability issues for listeners, and tools like Suno or Notebook LLM will likely significantly increase music quantity, not necessarily quality. And as AI lowers creative barriers, now is the time for platforms like Spotify to experiment and find beautiful use cases for AI, just like they did with AI DJ. You can create a Grammy hit with AI. Suno turns your ideas into polished tracks effortlessly. Suno just launched V4, which promises better audio, sharper lyrics, and dynamic song structures, enhancing its practicability for creators. In Suno, users just type in a prompt and receive a song, and this really empowers users to prototype and refine tracks with professional-grade tools very quickly. The ease to create a song invites more people to create, resulting in more diverse voices. But this also may increase the challenge of distinguishing authentic art from AI creations, such as stealing Drake's voice for Heart on My Sleeve. Technology really lowers the barrier to entry in this case, and we now wait to see if it adds more value than confusion to the creative process. Are AI reasoning benchmarks more PR than progress? Top models like GPT-4o show significant drop-offs when irrelevant clauses are added to questions, and the hypothesis here is that the performance decline with added noise is because current large language models cannot perform general logical reasoning. They solely replicate reasoning steps from their training data, meaning if they haven't solved it in their training, it's unlikely they can solve a new problem. And this use of static data sets risks really overfitting and doesn't necessarily translate to real-world reasoning. For example, the finding revealed that large language models exhibit noticeable variance when corresponding to different versions of the same question. But there's hope. Innovative techniques like ScaleQuest are yielding performance improvements for mathematical reasoning. ScaleQuest works by fine-tuning models with a dataset of 1 million problem-solution pairs, training a model in 2 stages on what question to ask and how to best solve a particular question. So basically, special training for reasoning. And developers need to push beyond benchmarks and focus on these real-world applications of reasoning, because reasoning is the next 10x step for AI.